Okay, everyone, I am back and we are at part two. So we are ready to go ahead and begin practicing confidence intervals. Hopefully, you went ahead and got your materials that you needed to get. But now that you have a basic understanding of how to locate the Z for these problems, we're going to go ahead and move on to calculating confidence intervals. You can also find this formula on page 166 of your textbook. But this is just a breakdown of the formula. And in this particular formula, we know the population standard deviation. And so that's what, let me highlight that really quick. That's what this is right here. The lowercase sigma, that is um, the population standard deviation. Okay. Now that's not always the case. We don't always know the population standard deviation. There are times where we don't know that. And on the next slide, you'll see that the formula changes when we don't have the population standard deviation. But for now, we would simply plug in the numbers into the equation and solve for the confidence interval. This is if we know the population standard deviation. And don't forget that since we're solving for an interval, we're going to get two numbers. And so as I go through and work through the examples, pay close attention to what I'm doing in those examples that I'm going to go through in practice. But these are the different parts and what each one of these items means within the formula. So you have the X bar, I call this the X bar. This is the sample mean. This is that Z-score that you found. Oh, I'm sorry, I forgot. You guys can't see what I am motioning towards. Okay, so this is the sample mean. All right, this is the Z-score. So you remember in the last example, right before I ended part one of the lecture, I came up with for 85%, I came up with a Z-score of 1.44. Or if you have a 95% confidence interval, 95% confidence level or confidence interval, we have the alpha of 0.05. And then when you split it in two, you find that Z-score. And the Z-score is, if I remember correctly, it was Z 1.96. That's what we would have right here. And it just depends on whatever our confidence level is going to be. All right. Then this right here, the funny looking O with the little cap, or if you look at it in Greek terms, the lowercase sigma, that is equal to the population standard deviation. All right. This N right here, as you can, it doesn't show, but that N is basically, N is equal to the number. So the number in your sample, that's what that stands for. All right. And you'll see me go through all of this as I go through the practice problems. But just to kind of, show you what each of these means, what each of these items stands for. All right. So as I said just a moment ago, we don't always know the population standard deviation. There are times when we don't. There are times when we don't know that information, and when that happens, we can substitute the population standard deviation for S, but only in certain circumstances. We can't always do that. So the circumstances where we can do that is when we have a large sample. And for the sake of this book and for what I tend to do, a large sample is going to be anything where your number is greater than or equal to 100. Now, researchers from different disciplines will sometimes differ on what's considered a large sample. I've seen some say that 50 participants is a large sample, whereas I know for a lot of the work that I do, they want you to have at least 100 participants. Since our course textbook considers 100 to be a large sample, that's what we're going to go with. All right. So that's what we're going to go with here. And so in this situation, when your sample, when you have a population standard deviation, all right, population standard deviation, when that is unknown, so remember, this is population standard deviation. Uh-oh, I didn't spell that right. Okay, well, you know what that's supposed to say. So population, let's try that again. Standard deviation. Okay, I wrote too fast the first time around. So when that information is unknown, that's when, yeah, when that information is unknown, we have to have a large sample of 100, but we can use the sample standard deviation. Okay, sample standard deviation. So remember that the S stands for sample standard deviation. So that's what this is. That is the sample. I'm just going to put SD to save on time. So that is the sample standard deviation. All right. But our formula, as you can see here, it changes. Everything over here on this side stays the same. It's this side is what where things tend to change. So everything within these parentheses changes. You use a sample, you can use the sample standard deviation, but instead of dividing by the standard deviation of just the number, you have to divide by the standard deviation, excuse me, the square root. I don't know why I said standard deviation. You have to divide by the square root of the number minus 1. And this is done to account for the fact that S is biased. So just like in the first formula, you plug in the numbers. You plug the numbers into the equation. Okay. All right. So, and also don't forget, when you're solving for a confidence interval, you're going to have two separate numbers. You're going to have your number that's the low end of the confidence interval and your number that's the high end. Now, this note that I have down here at the bottom, some of you may be you may be thinking ahead a little bit and you say, well, what happens when you have a small sample, a sample that's less than 100 cases, and you don't have the population standard deviation? Well, that's a totally different situation, and we'll start to deal with that in chapter 8, but that's when the person would use a totally different distribution that hasn't been introduced to you yet. You'll learn about that distribution when we get to chapter 8. Okay, so this is going to be example 1. And at this point, I'm actually going to switch over to my OneNotes, this right here. It's the same thing that you just saw on the screen that was in the PowerPoint, but rather than try to write around all the stuff that's on the PowerPoint, I'm going to do it here. But I do have the steps where, on the PowerPoint, it shows the various steps of the problem. I do have that here, okay? So, but I'm still going to go through and do all steps so you can actually see me walk through this, or you can practice and walk through it in real time with me versus saying, well, how did they jump from this 200 to the 14 divided by 14? You'll see me calculate and go through all of the steps. So as you guys may be aware, or maybe you've picked up on by now, some of the things that I like to do when it comes to working out the problems. I like to highlight the important information. So we know that we have a sample of 200 residents. We know we have a mean IQ of 105. And in this particular problem, we have the population standard deviation, and it's equal to 15. We also know that our alpha in this particular instance is going to be 0.5 because they're telling us they want us to calculate a 95% confidence interval. And remember what I said about the alpha. Don't just go back to the back of the book and look at table C and look at the area for 0.05. Remember, for a confidence interval, you've got to divide this by 2. Then you look the number up. But we've already been, we can look back and we know that we know what the z-score is for this. Okay, so at this point, let me go ahead and write out all of my information. So I know that my number is going to be equal to 200. Okay, so the number in this instance is 200 because that's how many people are in my sample. I know that my mean, so X bar, my sample mean is equal to 105. I know that I have a population standard deviation is equal to 15. And I know that my z-score is going to be 1.96. That's something that you need to find before you start working on the problem. So get all of your information set up, and then let's go ahead and just walk through the steps. So on the first part of the problem, I'll do the CI, I'll write that out, but I think thereafter, I probably won't write that part out. But it's basically, here's the formula right here, in case you need to see it again. There's the formula. But typically I start off with the formula just like they've done here, but for the sake of space and time, I'm not gonna do that. I'll just go ahead and plug in the numbers. So I know that my mean is 105, so there's my mean. So 105 plus or minus, because remember, this is an interval. So we need that low end and that high end. So I know that 105 plus or minus, I have the Z. I know that the Z-score is 1.96. And so let's see what's within the parentheses. In the parentheses, I have the standard deviation of 15. And that's going to be divided by my number of 200. All right, so I've written out my problem. Now let's go ahead and start working on the various calculations. All right, so it's equal to 105 plus or minus, and you guys know I like to write out every single step, okay? So 15 divided by, now let's go pull up the calculator. You can see me do it on here. Find the square root of 200. The square root of 200 is going to be 14.14. That matches what we see here. So now you know how we got this number, this 14.4. That 14.4 is the square root of 200. And for the sake of time and space, you know, as I'm writing the problems out, I'll round out to the second decimal. The times that I don't do that is when I'm dealing with stuff like proportions. All right, so next step. So next step, write it all out again. I know this may seem tedious to some of you, but if you write it all out, it helps you see where maybe if you end up making a mistake, it helps you see where you went wrong. So let's go ahead and look at 15 divided by 14.14. So 14.14. That's going to give us 106.08. And because that 6 is followed by a 0, I don't need to round up. I can go with 1.06. So 1.06. And since I'm rounding up to be consistent, sometimes I'll just automatically hit the multiplication button and multiply by 1.96. But, you know, since I'm writing things out a certain way, I'll do those calculations the same way. So at this point, now I need to know what is 1.96 times 1.06. That's going to give us 2.0776. Now, since I am rounding to the second decimal place and the number after that first 7 is more than 5 or 5 or more, I round up to 2.08. Okay, so when I write this out, it's going to be 105 plus or minus 2.08. And when I get the lower end, so what this basically means is that scroll up a little bit so you can see. Okay. So what this basically is going to mean is that my confidence interval, so 105 subtract 2.08 is going to be 10292. Okay, so my confidence interval is equal to 102.92. Let me double check that. Okay, now Under normal circumstances, I know that 105 plus 2.08 is going to be 107.08, but just for the sake of teaching and making sure that I employ good practices, I do the things that I tell you guys to do. I'm going to take that 105 and add 2.08 to it, and that gives me 107.08. So my confidence interval is hang on a second. There we go. This is my confidence interval. So it is 102.92 to 107.08. Okay. So here in the example here that appears in the PowerPoint, and that's this right here, they stop at this part. Okay. You can do that, but typically I want to be able to see that you know how to carry through and follow it all the way through, because there are going to be times where you actually have to write up the interpretation. And we'll get to that. You'll see how to write up the interpretation once we finish with example 4. Okay, so example 2. Let's get back to, let's do my highlighting. Now you'll notice in this particular example, they don't write out all the steps. You know, you go to this step, and then next thing you know, you get to the final step. So you'll see a lot more steps that I do than what appears right here. Now, in this particular problem, we don't know the sample, excuse me, not sample, but the population standard deviation. Because remember, that's what this number or this symbol stands for. We don't know the population standard deviation. What we do know, we know the mean income for the random sample is, the mean income for a random sample of 500 community residents is $45,000. Now, when you're reading this, don't make the mistake of thinking that the mean income follow the number 500, which is what directly follows these words right here. Don't make the mistake of thinking that is the mean income. That is actually your sample, okay? It's just the way the question is worded. So your sample is 500. The mean income for that sample is $45,000. And then they say with a standard deviation of $200. And notice they don't say that it's a population standard deviation. It basically, everything in this sentence is about a sample, because they're saying the mean income, you know, you have a mean income for this sample, and that mean income basically has a standard deviation of 200. Now, if the sentence was something about your population average, the population or the mean income for the population is 50,000 with a standard deviation of $1,000, then that $1,000 would be your population standard deviation. But that's not how it's worded here, okay? All right, so let's go ahead and walk through the steps. Step number 1, we know that the number is equal to 500. Actually, I want to bring this over a little bit so I have more space. We know that the number is equal to 500. We know that the sample mean is equal to 45,000. We know that the standard deviation, the sample standard deviation is $200. And we already know just from other problems, after a while, you start to recognize, you know, what these numbers should be. But we know that the Z is going to be set at 1.96. All right, so let's go ahead and write out our problem. All right, so CI is equal to, our mean in this case is 45,000 plus or minus 1.96, which is going to be multiplied by the standard deviation, the sample standard deviation, which is 200. That's a 2, not a Z. Divided by the square root of the number, which is 500, minus 1. All right, so let's start doing some of our calculations. All right, so let's go here. Equal to 45,000 plus or minus the 1.96 with the 200 divided by the square root of 499. I know some of you are like, you really don't have to write out all these steps. It helps, okay? I know for some people it may seem tedious, but it does in fact help. It helps you figure out where maybe things go right or don't or go wrong. Okay, so 45,000 plus or minus 1.96. This time that's going to be multiplied by 200 divided by, so let's go ahead and get that information, clear out the previous problem. We need the square root of 499. That's, uh-oh, I did something wrong. Okay, 499 square root. Okay, that's going to be 22.3383. Well, that second 3 is followed by an 8, so we're going to do 22. We're going to round up. So it'll be 22.34. So 200 divided by 22.34. All right. So here we have, that's going to be equal to 45,000 plus or minus 1.96. Let's do this calculation real quick. Clear this out. So 200 divided by 22.34. That's going to give us 8.95, and that 5 is followed by a 2. We don't need to round up. So 8.95. Let's go ahead and get that ready. 1.96 multiplied by 8.95. It's going to give us that 17.54. And I'll speak on this in just a minute, but let me go ahead and write my information out. Equal to, so again, I'm just following each little step, and you can see where I make my changes and I do my calculations. So 45,000 plus or minus, what did we say? I said 17.54 is what I got, but I want to direct your attention to something. Okay, so here in the problem that came from the book, they got 17.55. Well, remember when I did my calculation, I got 17.54. When you write out your problems as a whole, this is where I could see where if there are differences, that'll give me that information. So I'm gonna do something real quick so that I can maybe demonstrate where that difference comes from. Because I can't even, for mine, I can't even round up to 17.55, but this is where 9 times out of 10, the difference comes from. So let's go back up to this step. So I am here where we've got the, actually, no, I'm right here at this step right here. This is where I'm at. Uh-oh. There we go. Let me just use the highlighter. So this is where I'm at to demonstrate this difference that I was talking about. All right, so remember I did 200 divided by 22.34, and I got this long number. Well, if I didn't round it up and I just multiplied by 1.96, that's how they're getting the 17.55. So it depends on how you're doing your addition and subtraction, rounding up. I typically do the problems both ways so that when you guys answer questions, if your number is 1 or 2 off from what I get, I know why. And typically for something like this, I give you credit either way. So if you are rounding up to the second or third decimal place, don't start panicking saying, well, she got a number different because she rounded to the second decimal place. I know that that is the case. And so I do take that kind of stuff into account. Now, for the sake of, for argument's sake, we are going to use what the book used. We're going to use that, and I'll put the number over there in just a minute. We're going to use that 17.55, but let's go ahead and do 45,000 subtract 17.55. All right, so that's going to give us 44,982.45. All right, so let's come on over here. So now we will do our confidence interval. And we know that our confidence interval is equal to, let's look at that number again, 44,982 and 40.45. And it goes all the way to, and let me do good practices, 45,000 plus 17.55, which is going to give us 45,000. Let me double check that. 45, comma, yes, okay. So this is our confidence interval for the problem that did not have a population standard deviation, all right? All right, so let's look at another problem. This one, however, has a slightly different alpha. The two problems that we just did, the alpha was set at 90%. So for this one, we're going to do a different alpha, if you will. And if I didn't have the problem over here, I would say, hey, try to figure out what which formula to use. But because the problem is already over here, I'm not going to have you go through all of that. Plus, this is in the book. But let's just highlight the different bits of information. We know that we have a random sample of 178 households. The average TV viewing is 6 hours a day. And we know that the standard deviation for the sample is 3. And we have a alpha of 0.10. Now, since we know that standard deviation of 3, we know that we're going to use a slightly different formula, all right? Now, let me go ahead and go through my steps. I think at this point, some of you are getting used to all of the different steps that I like to take. But again, follow along. All right, so the N, we know that the N is equal to 178. We know that the X bar, the sample mean, is equal to 6 hours a day. We know that the sample standard deviation is equal to 3. And because our alpha is different, remember, we're not going to have a z-score of 1.96. Our z-score this time around is 1.65. So z is equal to 1.65. All right. Okay, so my space is a little limited on this one. So I'm not going to write out the CI. I'm just going to start with the equal. Okay, so this one is going to be equal. We know that our sample mean is 6. So 6, actually, I want to start this down a little. Okay, so we know that our sample mean is equal to 6. So plus or minus, we know that our Z is 1.65. Now let's go ahead and do everything in the parentheses. We have a sample standard deviation of 3. That's going to be divided by the number of N, the square root of the number N 178 minus 1. All right, so at this point, I'm just gonna work through the steps. I'll try to talk as I'm working through them. And I'll try to go at a reasonable pace. I tend to work through these problems pretty quickly. All right, so let's go ahead and go for it. All right, so 6 plus or minus the z-score of 1.65 divided by, multiplied by 3 divided by the square root of 177. All right, so next line is equal to 6 plus. All right, so 6 plus or minus 1.65 with 3. I'm going to do it like this to so that I don't bump into this problem above. All right, so let's go ahead and get that information. The square root of 177 is going to be 13.30, and it's a 4 following the 0, so we will not round up. We will just have 13.30. All right, so this is going to, the next line or the next step is 6 plus or minus 1.65 multiplied by the outcome of 3 divided by 13.30, which is going to give us 0.22255. That's going to give us, rounded up to the second decimal place, 0.23. All right, so our next step will be 6 plus or minus the outcome of 1.65 times 0.23. That gives us 0.3795 rounded to the second decimal place. That will be 0.38, which is the same as what we got up here. So let's go ahead and write out our confidence interval. The confidence interval is going to be equal to, all right, so 6 subtract 0.38 will be 5.62 to 6.38. Let me go ahead and do that addition just so you can see that. 6 plus 0.38. That's how you get this, the 6.38. Okay, so there's that problem. All right, so with this particular problem, it's the same as the one before. And yes, this is, it may seem again repetitive, but we're going to go ahead and practice this problem. This actually will be the last practice problem for this set, but we'll practice this problem and then you get to see the interpretation. Okay. All right. So I'm not going to go through and highlight because we know what that information is from the problem above, but I will write it out here. So n is equal to 178. The sample mean is going to be equal to 6. The sample standard deviation is equal to 3. And the z-score is equal to 1.96 in this problem. Because remember, we now have an alpha of we have an alpha of 0.095. So that z-score is going to change. All right, so let's go through the steps. Confidence interval is equal to 6 plus or minus 1.96 with the standard deviation of 3 divided by the square root of 178 minus 1. All right, let's come down here. I'm going to go down a little bit further so that I have more space. So equal to 6 plus or minus 1.96 with 3 divided by the square root of 177. And so, all right, I could be lazy and I could just go back up to the problem above and copy this information, but I'm not going to do that. So 6 plus or minus 1.96 multiplied by 3 divided by, all right, so let's get that square root of 177 again. And that is 13.30. All right, so let's scroll down so I have more space. All right, so now we have this being equal to 6 plus or minus 1.96, and we get, let's do the math for this. So 3 divided by 13.30. That is going to be, remember that was 0.23 because we rounded that 0.225 up to, we rounded it up to the next number, which is the 0.23 because we're doing 2 decimal places. So, and this is where when you do the math, 6 plus or minus 1.96 times 0.23 is going to be, let's calculate it out just so you can see it. 0.23 2, 3 is going to be just like it says there in the problem that's worked out, 0.4508. And because we're doing 2 decimal places, we leave it at 0.45 because the number after the 5 is a 0. We do not need to round up. All right, so 0.45. So this would be equal to, excuse me. So our confidence interval is going to be equal to, that is going to be, I believe, 5.55, but let me do the calculation. All right, yes. So it's our confidence interval is equal to 5.5. Oops, I don't know what I'm doing. There we go. It's equal to 5.55 to 6.45. All right, so just to show you how I got 6.45, 6 plus 0.45. That's how I got 6.45. So remember this information, maybe write it down somewhere. But this is the last example. What I'm going to do now, before I take us to part 3, I want to make sure you see how to interpret something like this. So I'm going to switch back over to the PowerPoint. And let me go through example 1, 2, and 3. So as you can see in the PowerPoint, the stuff that was on the right side of my screen, that's in the PowerPoint, okay? All right, so this was that last problem that we worked out. And I'm not sure why, but for whatever reason, I have 5.56 in here. So we're gonna ignore that and say, it may have been some of the calculation, but we're going to say 5.55. So this would really be 5.55 then equal to 6.45. Thinking it must have been a typo, but it was a typo I kept making. Okay. So when it comes to saying this out and how we interpret some of these problems, this is the interpretation for problem 4. So for 95% level, we can estimate that households in this community average 6 plus or minus 0.45 hours of TV watching every day. That's a little bit odd, and that's an odd way to say it. So what we could say instead is, let me put the 5.55. What we can say instead is, if you're writing it out mathematically, it would look like this, what I have written in red, this right here. That's what it would look like mathematically. And basically what we're saying, the verbal or the written interpretation of that would be, we estimate that the population mean is greater than or equal to 5.55 and less than or equal to 6.45. And, we can say that this interval has a 0.05 chance of being wrong. In other words, we're saying that this is at the 95% confidence level. So that's essentially how you would interpret and how you would say some of this. So just real quick, final points, wrap up in terms of confidence intervals. So even if the statistic is as much as plus or minus 1.96 standard deviations from the mean of the sampling distribution, the confidence level is still going to have to include that value of of mean. And this right here, I meant to mention this funny looking M, if you will. Some people say it looks like a funny looking M. Some people say it looks like a U. This is basically the population mean, okay? That's what that stands for. It's mu, and it stands for population mean. I tend to go with funny looking M just because mean, mean equals, M equals mean. So this right here, that is basically equal to the population mean. Okay, so population, that's what that stands for. And usually when you see me write it out, it looks like that. It just looks weird when I write it out, but that's the best I can do. Okay. All right. So only basically what we're saying when we say at the 0.05 time, at the 0.05 level, that, a way to think about this is that 5 times out of 100, the interval, the mean will not be in the interval that we've come up with. That's basically kind of how you would think about that. Okay, so that essentially wraps up part 2 of the lecture. Me going through and practicing and doing confidence intervals. We have one more section left. We have confidence intervals for sample proportions, and then kind of like a chapter wrap up to just kind of reiterate and summarize some of the points that have already been made. So we do have one more set of practice problems to look at, but that particular set I won't go through and write them out hand by hand. I'm going to point things out to you on the screen. All right, see you for see you for part 3.